Hi, this video is about interference in waves. Now normally two things cannot be in the same place at the same time. If they try to go in the same place, they collide with each other and bounce off or stick together. But waves are a little bit different. Waves can exist in the same place at the same time. They can pass through each other or be one on top of another, and they can exist in the same place at the same time. That's what makes waves a little bit different. I want to show you this with a Slinky today. And what I'm going to try to do, it's hard to see this, it's hard to demonstrate this exactly, but what I would like to try to do is I want to pass a wave to the right and I want to pass a wave to the left at the same time. And I want to see what happens when these two waves meet in the middle. And there's different things that can happen based on the kinds of waves that I send, but I'm going to try to send a wave like this to the right and then a wave like this to the left. What will happen when they meet in the middle? So let's try it out. Let's see if we can actually demonstrate this. Okay. So I'm just going to practice sending a wave first. So there's a wave. Let me move it down here a little bit. Okay, they're pretty fast right now. Let's see if we can slow them down a little bit. Okay. All right, let's try it like this. So I'm going to send a wave to the right and a wave to the left at the same time. Watch what happens when they meet. Okay, that was really fast. Let's try it again. There we go. That was pretty good. That was a great one. What happens when they meet in the middle? You should notice they jump up. So in the middle here, when they meet, they add together to make a wave that's twice as tall as originally. Let's try it again. Now that you know that, let's see if we can see that as I do it again here. But you can see just for a moment in the middle there, it looks like the waves add together and interfere with each other. We call this interference in physics. Specifically, this kind of interference builds up a stronger or taller wave, so we call it constructive interference. It constructs a bigger wave. So that's constructive interference. Well, let's look at the other kind of interference, which is the opposite of this, and that's destructive interference. So in destructive interference, instead of having waves add together, we'll need to send a wave going the opposite way, like this. So we'll send one wave that's got positive displacement, one that's got negative displacement. What do you think will happen in the middle here? Well, what should happen is the crest of this wave should fill in the trough of this wave, and you should have nothing in the middle. But again, this all happens very fast with the Slinky, so it'll be hard to tell. But we should be looking at basically a canceling out of the two waves in the middle just for a second, but then they'll continue passing through each other, and at the end, we should have this negative displacement moving to the right, and the positive displacement is still moving to the right over here. The negative one is moving to the left. They should pass through each other. So that's what we're going to try to observe this time. Like I said, it happens very fast, so we'll try our best here. I'll try my best. Move it up here. Okay, so let's do it a few times. So you could put a point right here on this part of the Slinky, and it looks like it's not really moving too much. Now contrast that with the constructive interference, and you'll see the middle move. So here the middle is definitely moving. When I do it the same way, we get constructive interference. You can do constructive interference in the negative direction too. But if you do opposite directions, they just sort of cancel out. and you don't really have much of anything. So that's a little bit about interference. That's all I've got for you in this video. Remember, humility is not thinking less of yourself, it's thinking of yourself less.